Hi Aunt, today let's discuss about superposition theorem. So superposition theorem, first we have to discuss the statement of the superposition theorem. So for what type of network we can apply the superposition theorem? So it can be a linear network. So the network contains two or more sources. So it can be a current source or voltage source. So how can we prove the superposition theorem? So the response in any element. The response means it can be a current or voltage across the element. Current or voltage across the element. So we have to prove the superposition. How can we prove the superposition theorem? So we have to find out response of a particular element. We have to find the response of a particular element by keeping all the sources acting. All the sources are active. Okay. Then left hand side of the equation. How can you prove that? We have to keep the individual sources acting alone, and after that finally you have to sum up all the responses caused by the individual sources. So the two values should be same. So this is the way how we can prove the superposition theorem. So come to the back to the statement. Sum of the response caused by the individual sources acting alone while the other sources are non-operative. How can we make a source non-operative? So that is, we have to, if it is a current source, you have to open the current source value, and if it is a closed source, you have to, if it is a voltage source, we have to close circuit the voltage source. That in the statement they have given us, you have to replace the current and voltage sources value by short circuit and open circuit across the terminals. Okay, and this type of theorem, that is superposition theorem, is valid, not valid for the power response. We can find out only the voltage or current values, not the power value. Okay. So here we can look at the example numerical problem given. So in the problem, what is the problem given? Problem statement: find the current passing through the 3 ohm resistor in the circuit. So we need to find out current flowing through the 3 ohm resistor. That is the response caused by the response of the element 3 ohm. The response is current here. Then the element is 3 ohm resistor here. Okay. So we need to apply the superposition theorem for this one. So here one side of the equation can be proved. What I told in the statement, here one side of the equation can be proved by keeping the two sources, the given sources, both the sources should be active. So here the given sources are 20 volt source and the 5 amp source. So we have to keep both the sources active. So how can we find out the current flowing through 3 ohm resistor? So you can apply mesh analysis here. So by applying mesh analysis, you can find out the current flowing through the 3 ohm resistor. So here we can find the two meshes. So for the first mesh, you have to apply KVL. So you have to apply KVL, and you can get the equation as 20 is equal to 8I1 minus 3I2. And the second mesh, you can see this as second mesh as super mesh analysis. That is, I2 is equal to minus 5 amps. So the mesh current direction and the current source current direction is opposite. So you can write as I2 is equal to minus 5. Now you have to substitute the I2 value in the first equation, and you can get the I1 value. Now you know the I1 and I2 values, right? You got I1 and I2 values. Then you can substitute it as I3 is equal to I1 minus I2. So which currents are flowing through 3 ohm resistor? Both I1 and I2. So you can write as I1 minus I2. I3 ohm is equal to 5.625 amps. And next you have to, so you got the value of the left hand side of the equation. Now you need to solve for right hand side. What is our right hand side? We have to keep the individual sources acting alone, and the responses should be added up. So first we have to keep the 20 volt source acting alone. So how can we keep the 20 volt source alone acting? By you have to inactive the other current source. How can we inactive the current source? You have to open circuit the current source. You have to open circuit the current source. So what is open circuiting? That is, you have to remove and keep the terminals as open. Now you can look at the circuit. When 20 volts was acting alone, open circuit the 5 amps current source. So this is the final circuit you will get. So while the 20 volts was alone acting, how many meshes you are having here? Now you have only 2 meshes. Now apply KVL to this mesh. So by applying KVL, so 20 is equal to 8I1. So I1 is equal to 2.5 amps. So this is what I3 ohm does. You can look at here, I3 ohm does. This is the first response of the 3 ohm resistor only by 20 volt source acting alone. You have to inactive other source. Next, when 5 amps source acting alone, you have to inactive the voltage source by short circuiting the voltage source. You have to short circuit the voltage source. So now short circuit the 20 volt source. So now you can get the 2 meshes. You can get the 2 meshes. Now you can apply the mesh analysis for the circuit. So if you apply KVL for the first mesh, so here you will get 8I1 minus 3I2 is equal to 0. So what about the second one? So the second one is a super mesh. So you can write as I2 is equal to minus 5. So you can substitute the value of I2 in the first equation and you can get the value of I1. Now you know the value of I1 and I2. So what currents are flowing through the 3 ohm resistor? So I3 ohm is equal to I1 minus I2. Both the currents I1 and I2 are flowing through the 3 ohm resistor, but the current direction of I1 and I2 are opposite. So you have to write as I3 is equal to I1 minus I2. So you can get the value of I3 ohm double dash here. So by summing up, the response caused by the individual sources acting alone, while acting the 20 volt source alone, you can get the value of I3 ohm dash as 2.5, and while the 5 ohm source alone acting, you can get the value of the current passing through 3 ohm resistor as 3.125. So if you sum up the value of 2.5 and 3.125, you can get the value as 5.625 amps. So this is the final equation. So you can verify here by keeping both the sources active. While keeping both the sources active, the total response of the element, the total current passing through the element is I3 ohm is 5.625. And what about while the sum of the values in the second hand side of the equation, I3 ohm is equal to 5.625. So both the values are same now. So hence you can say the superposition theorem is verified. So what we can conclude here as the superposition theorem, the response of any element is equal to the algebraic sum of the responses caused by individual sources acting alone. How can we make the individual sources acting while other sources should be non-operative? How can we make the source non-operative? That is, if it is a voltage source, you have to short circuit the terminal. If it is a current source, you have to open circuit the terminal. So in this way you can make the sources inactive. So you can make only one source active and another sources. So in this example they have given only the 2 sources. So if more than 2 sources given, if 3 sources given, you can make only one source active. Other voltage or current sources should be inactive. So in the same way you can make in the same. So here you can look at this.